think of chemistry, we tend to think of atoms, the periodic table, compounds, isotopes, and so on, forgetting that there are more minor details too. Some of the most essential components of chemistry comes from a solid foundation and understanding of things like significant figures. Hi, I'm Songy Ra, and today we are going to be covering a science lesson on significant figures. So, significant figures means the number of digits to determine the degree of accuracy of a value. So we only account for values that aren't placeholders and count values with significance and give us additional information. Let's take a look at this example. 28040. This has 4 significant figures. The first 4 of 5 numbers hold significance, while the 0 is a placeholder. The following example, number 2, is 2.840. Like the previous example, there are 4 significant numbers. However, unlike the first example, the 0 in the decimals hold significance because it tells us that the number wasn't rounded up or down, since if it was 2.84, it is less accurate than 2.840. 2.84 could have been rounded from like 2.843 or 2.842, but 2.840 is a lot more accurate than 2.84. Example number 3 is 0002. This is 1 significant figure because the 3 zeros in the beginning are just placeholders. Adding those zeros don't add any additional information to this number because it is always implied that there are no other values that change this number if it was to be just 2. However, if it was 0002.0, then this would be 2 significant numbers. The first 3 zeros are still placeholders like before because it doesn't add any more additional information. But the 0 after the 2 is significant because it is after a decimal point and tells us that 2 was not just rounded down from a 2.3 or 2.2, it is a 2.0. So, using what we learned from these examples, there are generally 4 rules to determining significant figures. Number 1, zeros between 2 non-zero digits are significant. Number 2, leading zeros are not significant, like we saw with the example of 0002. And number 3, zeros to the right of decimals are significant. And finally, number 4, non-zero digits are always significant. Now, sig figs are used in a variety of ways, one being math, and calculating the area, the volume of a graduated cylinder, or finding the density of an object. The list goes on. It's quite simple, to be honest. It is what we know. Addition, subtraction, division, multiplication, and it's all applications of significant figures within them throughout chemistry. In addition or subtraction with significant figures, we should follow these rules. Number 1, find the place position of the last significant digit in the least certain number. Add and or subtract the number in your calculation as you normally would. And finally, round the answer to the place position of least significance that you found in step 1. Let's try an example. 1.23400 plus 1.111 just regularly would be 2.34500. But we see that 1.111 is the number with the least significant number of digits, which is 4 significant figures. So we have to round 2.34500 to 4 significant figures. So we just cross out those last 2 zeros, and it would be 2.345. Now, in this equation, it is a subtraction problem. 1.8657 minus 8.05. Now, we know that 8.05 is 3 significant figures because the 0 is also included because it's in between the 2 digits and it is after a decimal point. Then just subtracting it regularly would equal to negative 6.1843. But since we do have to round to the 3 significant figures, the 3 at the end would just cross out, and it would be negative 6.18 as your final answer. Multiplication and division are pretty similar. Number 1, for each number in your calculation, find a number of significant figures. Number 2, multiply and or divide the number in your calculation as you normally would. And number 3, round answer to the fewest number of significant figures you found in step 1. Here's another example. 143.28 multiplied by 8.500. So 8.500 is 4 significant numbers because zeros in decimal points always matter and they are always significant. So just multiplying regularly would be 1217.88. And since we need to round to 4 significant numbers, we just ignore the last 88, but also rounding up since 1217.88 would round up to 1218, which is still 4 significant figures. This is an example for division. 8.05 divided by 1.1167. We know that 8.05 is the number with the least significant number of digits, which is 3 significant figures. And just regularly multiplying or dividing would be 7.2087400038. Quite long, right? So when we have to round to the nearest significant figures, then it would be 7.21, which is 3 significant figures too. Now let's apply what we just learned to a density problem to solve the density of an object. Number 1 would be mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. The mercury used to fill the cylinder weighs 306.0 grams. From this information, calculate the density of mercury. Well, we already know that we need to find the density, and we know the mass is 306.0 grams, and the volume is 22.5 milliliters. And the equation of a density is D equals mv, or density equals mass over volume. Using this equation, we can set it up. We know that we have to find the density, so it remains as D equals, and then the mass 306.0 over 22.5, the volume. And simplifying that would be 13.6 because the three significant figures from the 22.5 apply to 13.6, which is also three significant figures. And the units we would use is grams over milliliters. Let's try another problem. What is the weight of the ethyl alcohol that exactly fills a 200.0 milliliter container? The density of ethyl alcohol is 0.789 grams over milliliters. Like before, we know the equation is D equals M over V, but we do need to simplify that to M equals dV because we are actually given the density this time, and instead we need to find the mass since we are also given the volume, which is 200.0 milliliters. So D equals mV, which is then M equals dV because we changed the equation so that we are finding the mass. And then we just substitute the values of D and V. So M equals 200.0 times 0.789 would equal to 157.8 grams because the least number of significant figures is actually 4 significant figures. So it is 157.8 grams. And this is a basic introduction to significant figures and problems that we would probably use this in. However, there are other things we would use in chemistry using significant figures, like calculating accuracy versus precision, and other important things like atomic weight and average weights between elements. But that is for a later lesson. So that's all for today, and see you in the future.